Hello, in this video we are going to start this unit Fundamentals of Computer Vision and its Application. Now where are we in syllabus? This is a new unit and we will be covering some different topics within this unit. Initially we are going to study the introduction and the goal of computer vision. In the next part we will be studying about the basics of image processing and its formation. We will be also studying CNN, convolutional neural network. This is very famous topic these days. And then we will be discussing about different use cases. Face recognition is one use case, and we will be also discussing about the self-driving cars and also video surveillance for traffic. Now the introduction and goal of computer vision. What is computer vision? Computer vision is a field of study focused on the problem of helping computer to see. Now you are using your mobile phone these days, and you see that when you are clicking your friend's photograph in your phone, the box comes up around their face, and it is trying to focus on that face, or maybe it is trying to predict the age of that person or the gender. So all those kind of things are part of computer vision. This is only one example, and according to this page 83 of computer vision book, at an abstract level, the goal of computer vision problems is to use the observed image data to infer something about the world. So this definition is self-explanatory, and mainly the goal is that you want to use the observed image data to infer something. So whatever is being perceived, even for us human beings, when we see something, the meaning is different for me. The same thing, if shown to you people, it will be different for you people, because you have different stories about every object around you, right? And based on that, computer vision is not about like we are perceiving, but it's more about just basic recognition and understanding the surroundings better. So machine intelligence is not at that level of human intelligence right now, so it's not about the perception, it's more about what is around and just being present. Now computer vision is mainly deep learning these days. Why is deep learning being given more weightage these days? So the reason is simple. Let's say that you have an image of this cat, and this can be recognized as a cat, and even you want to have different processes which may lead you to different inference of this image. Let's say now you want to solve this problem using supervised learning. Supervised means that a human intervention is required. That's the simplistic definition of supervised learning. So let's say that if I have thousands of images of cats like these, and I have their names, or maybe types of cat, or maybe just cat or dog recognition problem. Now let's say that I am writing cat as the label of this image. Now this cat is being sent to the supervised learning model, and then you are recognizing something and just trying to solve your problem. Now let's say that this cat is being given input to the network, and now you are just giving the image, right? You are just giving the image as the input. The output will be cat. This should be the output of your classifier, right? Similarly, if you are doing this through unsupervised learning, you will not be giving this cat as the label. The label will not be sent here. It will not be sent here for the unsupervised learning. You are just sending the image. The image of cat will be going as the input, and something based on the algorithm behind the unsupervised learning, the output will still be cat, right? The difference is simple. You are saying this is a cat through the label using the supervised learning technique, and you are not giving the cat as the label while doing the unsupervised learning. And even the semi-supervised learning, there are multiple techniques that will be discussed that you will also know over time. So semi-supervised learning means that you are having data somewhere the labels are given and somewhere they are not. In real world the datasets are like that only, right? And even this reinforcement learning, this is also part of computer vision. Why? Let's say that there is this mouse which is going to find its cheese within the environment. This is the environment. The environment is this building or maze, so it has to find the cheese and eat this cheese, right? And based on that the reward is given. So if it finds the cheese, the reward is given, let's say plus 10 points. and even if it is not finding the cheese over time, we will be giving minus 10 points, let's say for every 10 seconds if it is not moving or something like that. So reinforcement learning is mainly regarding the rewards, so plus 10, minus 10, plus 100, minus 100, all those kind of things. And then this is training images, this is a training set, right? And based on the training set, you are sending for the image feature extraction. Feature extraction is one of the process while doing recognition. And then for the classifier, let's say this classifier is SVM in machine learning, or maybe you are using deep learning, let's say CNN model. We will be studying about CNN later on, but let's say that you are using a CNN model to do the classification. The training labels, initially we had sent cat, so cat was one of the label, and trained classifier will be giving the output as cat if the cat image is going. Now, what includes computer vision? Computer vision has images, computer vision has videos. Within images, you may have 2D image which is made up of pixels. So, what is a pixel? Let's say you have this cat and this region is being zoomed in, and you will see that there are a lot of numbers. This is 8, this is 2, 22, then 38, and then 75. So, all these numbers are pixels, and based on these pixels, you are trying to solve your problem. And similarly, in 3D image, you have multiple types of data. Let's say voxels. So what is a voxel? So voxel and pixel are somehow related. How? So pixel full form is picture element, right? Picture element. And voxel means volumetric picture element. Some people in research community also refer to voxel as volumetric element. They skip the picture part, but this is how it is for 3D. So for 3D data, you may say that you want to use volumetric element of voxels, or even the meshes. What is a mesh? You will see, you will even be working maybe in the labs. And then the point clouds, then the RGBD. Point cloud is very famous. It became famous with iPhone X. So people who have iPhone X, who bought iPhone X, they were told that iPhone is using this 3D technology which is working on cloud points, and it is trying to do the face recognition based on that. And then the videos. Now videos are, everyone knows what is a video. Video is a frame per second of image. Let's say this is a video reel. Within that we have this 24 images. Okay, if my classifier, if my software goes through these 24 images within 1 second, it is a video and it is called 24 fps. Okay, so video is nothing, it's just frames per second based on images. And what is a regression problem, what is a classification problem, you will learn over time, but I can give you a overview. Regression means the output variable takes a continuous value. Let's say now you want to predict house prices, and you have multiple data, let's say number of rooms, okay, number of rooms, area, and location. And based on these three values, you are trying to predict the fourth value, which is the price of the house. Okay, let's say rooms are 4, area is maybe 500 square feet, and then maybe location is any city, uh, let's say Chandigarh, and then the price will be 1.2 crore, something like that. Okay, now this number may vary depending upon the location. If you're looking into Mohali or maybe Patiala, so location based prices are there. This rate might be uh, 80 lakh in Mohali, and maybe for Patiala it may be 50 lakh, something like that. So this number may vary over time. Okay, this is a regression problem. This is not a classification problem. Now classification is, it depends upon the class labels. Let's say cat and dog problem. So we have the image folder of cat, and we have a folder of dog, and in both the folders we have 500 images each. Okay, and you are trying to train your classifier on that. So classifier is trying to learn the features of the all the images of 1,000 images, total are 1,000 images, and then it is predicting if it is a cat or a dog. Okay, let's move ahead. Now, what does not include computer vision? What does not include computer vision is the NLP problem, the text data. Let's say you have a text data in form of maybe document, right? If you have a PDF of a book and you are trying to read something out of it, so it is not a computer vision problem, it is a NLP problem. You are trying to maybe make sense out of the words written there. Maybe you are trying to predict the next page by reading the first page of the PDF. You are trying to predict the second page of the PDF by your predictor. So it is a NLP area. And audio data. You are listening to some songs, and based on that song lyrics, you are trying to make, uh, let's say initially you have a audio of the song. You are trying to convert this into the textual form. You're trying to print the lyrics out of the audio. So there is this audio, and then you're trying to write the text out of it, and then you are trying to maybe also predict the next word in the song. So prediction based on that. So all of these things, working on textual data or the audio data, this is not computer vision. Computer vision is mainly only about the images and the videos. Let's move ahead now. Now, areas of computer vision. There are different problems within the computer vision. There are different challenges. So one of the challenges, image classification. We have talked about it already. There is this image localization, detection, semantic segmentation, instance segmentation, image generation, pose estimation, domain adaptation, autonomous vehicles. So all of these activities and areas of computer vision, I will be showing you examples related to these now. What is image classification? Image classification means that there is this sheep within the image. Forget about this orange box around the sheeps. You are just trying to classify this image into sheep or not. Let's say sheep or not. You are just trying to give output as a sheep. It is a image classification problem. And now localization. Localization means this orange box, you are within the image, you are trying to localize the uh, object or the animal or the person. So this localization within the box, this box boundation, is called as image localization. Object detection means you are detecting multiple things out of the image. You are trying to detect multiple objects out of the image. Now within object detection, you can say this is the sheep 1, this is sheep 2, this is sheep 3. So these boxes are called bounding boxes. This is a term you might want to remember. Then semantic segmentation. Semantic segmentation means segregating different things within the image with different color. Now this road is gray color, sheep is orange color, grass is green color. So all these three things are segregated with different colors. So this is called semantic segmentation. Now within that semantic segmentation, if you also want to segregate different sheeps within this example, so this sheep 1, sheep 2, sheep 3, now road and grass is unaffected, but yes, sheep 1, sheep 2, sheep 3 are being segregated. This is called instance segmentation, because this one sheep out of the whole image is the instance of that image. Okay, you can read more about by going to these links. The slides will be given. Now pose estimation, activity recognition, and gesture recognition. So what is it? You can read more about on this link. And so pose estimation means if the person is standing or sitting, so this person is sitting, these two people are sitting, right? This person is skating, okay, this person is skating, and these two skaters are standing, so standing and watching. So this might come under advanced computer vision, but yes, this is a very famous problem, and many people are working on this problem. what they do is they make these landmarks, they make these points out of the joints of your body, and based on those joints they simply try to see that what the person is doing based on the movement. So this is one example. The distance between the joints may differ, and also the order of joints may differ, being in different positions. So this is a very interesting problem, and this also has a use case example, let's say, of yoga posture. Let's say you want to detect what yoga posture it is. So for that you will have to work on these points. So image generation, GAN 2.0. So there is this organization called NVIDIA. They have worked on this hyper realistic face generator. These two people may look real to you, but they are unreal. They are non-existent. They do not exist on this planet. How have this been done by NVIDIA? They have used this GAN technology. GAN is generative adversarial networks. This is a very famous deep learning technique, and based on this technique, they have generated, NVIDIA has generated these two different people. These are just two. I mean, within the research paper, if you go and read the research paper, whatever they have published, I'm sure that there are many examples like these. Domain adaptation. Domain adaptation means, let's say that some picture was clicked on day, that image is being converted to night mode. So day to night conversion is called domain adaptation. This is only one example. If you have this edges of the purse and you are converting it into this full colored image of the purse or the bag, so this is edges to photo domain adaptation. Black and white image to color image, this is also domain adaptation. Labels to facade, this is also domain adaptation. So these are all the examples of domain adaptation, and the definition is domain adaptation is the problem in which the task space is the same and the difference is solely in input domain divergence. So you can read more about it and go experiment about it. You can make projects out of it. Let's move ahead now. This autonomous vehicles is very famous these days. Why? One of the most famous company that is working on it is Tesla. They are working on autonomous vehicles, and even many people are using those vehicles in America, US these days. And this is Zook's company's model. What they have done is they have built this fully autonomous, all electric and built for riders. So I have seen the video on YouTube. Zoox has been acquired by Amazon lately. This is a 5-6 year old company, and what they have done is sitting within the car and you are taken to a location based on whatever location you put. Depth estimation. So maybe you can make an inference out of it. How is it working? It is very simple. If the object is at front, right, it will be lighter color, and if it is at the back, this car in the last, it is at the dark color. So depending upon whatever the distance of the object is from you while clicking the photograph, the color is being assigned dark to lighter. So this is a kind of a gray image, 0 to 1, right? This is a grayscale image. But yes, if you are very near, you are at the white level, and you are at the back of the image, you are at the dark black level. So this is called depth estimation. You can read about these things within the links. Few shot learning. So there is this called n-shot learning. N-shot learning means learning more with less data. So what they do is, let's say that you have a data set of face recognition of faces, and let's say that you have these 4 people having 100 images. So this is a 4 people data set having 400 images for only 4 people, and you are trying to predict which person is it, right? And only 4 people are there. So one of the ways that train your model on all the 400 images. The second way is you just pick one image per person. Aadhaar dataset is one of the example. One image of person A, one image of person B, one image of person C, one image of person D. Using just these 4 images, you are trying to predict if this new image, whichever has come, so which image is it? Does it belong to A, B, C, or D? Let's say this belongs to B. Now, how the similarity will be calculated is they will be using some technique which will match this B to this E and eventually get a B out of it. So this is a one shot learning, two shot learning, few shot learning, and short learning problem. So this is a generalized idea about this few shot learning. Anomaly detection. Anomaly means outliers, right? It is a famous thing called road less traveled. So it is a very famous quote. So let's say that most of the data is lying this side of the line, and only few points are on this side of the line. So this is kind of a outlier, and this is a very famous problem. People are working on this using keras and TensorFlow in deep learning. Okay, now about reconstruction. Reconstruction is a very famous problem. This is example of forensic facial reconstruction. Just based on the skeleton of the face, they are building this full face out of it. So this is how image reconstruction looks like. Image captioning. The input is this image, input is this image, and this text is the output. So this is a problem called image captioning. You are giving the inputs of the image, you are trying to get the text out of it. So these texts are the outputs and these images are the inputs. Input 1, input 2, and input 3. Output 1, output 2, and output 3. So this is a problem. This is solvable using deep learning. Visual question answering. Let's say that this image, we give this image as the input, and we are trying to say, we are asking the question to the classifier or my AI system, what is the mustache made of? So our AI system will look into the image and get the inference out of it that the mustache is made of bananas. So this has been done. This is a 2015 research paper, so it is quite old, but yes, this is a very famous problem of visual question answering. And where is computer vision right now? You can see that this actress Alison Brie's face has been replaced by Jim Carrey's face. So this is a example of deepfake. This is a very famous deep learning problem, and you have to maybe detect if the image is real or fake. This is a very challenging problem, if the image is real or fake. So let's say that this image is given the input, and you have to give the output into a real or fake. So this is a fake image, so output should be fake. And if this image is given as the input, the output should be real. So AI is being updated based on the ethics. So ethics will be taught to you, and there are many other computer vision problems also, which are very new and very challenging. Now the goal of computer vision. Typical goals include that we are doing some detection, we are doing segmentation, localization, and recognition of certain objects in the image, let's say human faces, and then also evaluation of results, segmentation, registration, so all those kind of evaluations. So you will be taught about different evaluation methods based on classification problem or maybe regression problem. Registration of different views of the same scene. Let's say you are seeing someone's face, and then you have to watch the face from the left side or maybe the right side. Only left profile or the right profile will be seen. So based on those things, your recognition has to work. Tracking an object through an image sequence, and mapping a scene to a three-dimensional model of the scene, such as model might be used by a robot to navigate the image scene. Estimation of the three-dimensional pose of humans and their limbs. Searching for digital images by their content base. So this is very famous, and people have been using this Google image search. So based on that, image retrieval is done. Thank you.